So when I ran out all the data, I got 98.4. It may be a little disappointing because it wasn't, say, better than before. But do note that when you look at it, the validation accuracy is actually much higher, which is a great sign. And the accuracy is also quite high, 99%. So this could be tweaked. Because it takes a long time to run, I'm not going to try to tweak this one, right? The modifications that we made were actually based on tweaking just the 2000 one. So I want to go back to that one. I'm going to go back to up at the top of the data. Do this with me. Do in rows equals 2. By the way, we don't have to do, I mean, you could do like 2500, right? You can make it a little different. If you do it a little differently, it's going to be a little different, right? Okay, like you can build up toward 20,000, I guess is my point. I would go higher if I was trying to build up toward that. But I do want to make some modifications here. And this did pretty well, right? Like in general. Something that we haven't tried yet, I've been mentioning, hey, you can use other optimizers besides Atom. The idea is that you want to use the one that kind of gives you the best, because you can pick, and again, these are just different kind of calculus techniques to deliver different ways of computing the gradient. So what are they? And I guess another question would be, is someone like, I don't know, these off the top of my head would be, I know some of them, but how do we find them? Well, when you have it set up like this, you can find them in like any given way. I don't think I quite said that right. You let's just look them up, okay? So Keras optimizers, okay? Type that into Google. And look at that. Look at that. I mean, Google searches have gotten very strong. You don't even have to click. You can see atoms listed first. What about SGD, stochastic gradient descent? Do you think simply from that you could in fact implement that? Let's try it. Let's see if that's enough. Okay. So go back to your notebook and find where you got the import atom. Well, is there an, type slowly, S, G. Look, I just typed in S and there it is. Why did I do that? Because if you're uncertain that it's an option, then you see it showing, now you can select it. Okay. So now I can, I forget what it, I'm going to run it, by the way. I want to run it with Atom first before changing it to see what the difference in the score is. Let me try to lower the batch size a little. Playing around with batch size today. Okay, so what we're going to do then, again, the cell's been run, right? It's just showing the output now, but the code has actually been running. It does show you, right, that it's fitting the data, so it hasn't done the last line. But we can certainly go back up here now and change it to SGD. Okay, stochastic gradient descent, and we can then see, right, hey, is it going to be better or not? And it's moving a little slowly, I noticed, with 32 batch size. Oh well. Did I run it all? I think that could be the issue. I think it's, yeah, it's still in 20,000. I didn't run it all. Okay. If code, by the way, this is a valuable lesson. If code is ever taking longer than you expect, check, because it could often be a mistake, right? So I'm going to stop this. So is it, it's not a mistake here. It's just I intended, right, when I changed the number of rows to actually rerun it using those number of rows so we can move more quickly in lecture since we have limited time. So I can just go to runtime and then run all. That's all. Now it's doing the SGD. We can compare that to Atom next. That's fine. And so you can see, right, see it's moving much more quickly. Okay. And the accuracy is quite low here. To start with, I guess it's just learning more slowly. It's picking up. And again, that's the thing with deep learning. Like, hey, it's okay if it starts slowly, right? As long as it's making progress, you're good to go. But based on what we've seen, that's much lower. And maybe that's one of the, I'm surprised that it would be that much lower. Is that one of the advantages of Atom, that Atom converges much more quickly? Okay. I don't know the details on the optimizers. I just know that Atom has kind of become the leading optimizer, but that it is definitely worth checking others. The other thing is if you ever end up with scores that are much lower too than expected, you can check like, you know. Okay, so I'm going to switch it to Adam here afterward to give us a comparison. And if we look at some of the other optimizers, you can in fact click on this and let's see like what does Keras provide here. I think it's worth, yeah, here we go, the available optimizers. I can tell you that I've seen RMS prop used. I mainly see those, the top 3, okay? I have not seen some of these other ones used. Not to say that they're not great and valuable, they're just not as common. And so if we look at one of them, I was trying to scroll down, it looks like they're showing you in general. If we click on one, like stochastic gradient descent, you can see it's just kind of general, like I don't know, I mean, you know, there's momentum is something that can be changed. That's something that we could potentially look into at some point. But you know, you can see here where they set the learning rate equal to 0.1. That's kind of the norm, is to change the learning rate. So how did it do? I got runtime disconnected. Interesting. I'll just reconnect. So it got 98.5%, right? So it ended up doing reasonably well. It just took some time to converge. Stopped at 20. That is totally the wrong one. That's the previous one. This is still going, actually. Okay. Right, because, yeah, we had the 200. And if we check down to where it is, let's scroll down. You can see it's slowly learning, right? So it's, I mean, accuracy is up now, up to 96%. And again, you can see Adam converging more quickly. Big advantage here. Okay. I may let this go. I may not. I may just stop it, right? Because you don't need to wait with me. I think what I'm going to do is pause the video. We'll see the score and then we'll switch it to Adam.